So we're going to be looking at the solution to this particular limit. I think I've done a video on this type of limit before now, which I tagged limit phase 2. So let's look at this now. We are asked to evaluate the limit of this function as x tends to 0. Let's see. The first thing you do is to substitute directly, okay? Let's substitute and see the result. So substituting, okay, we're given limit of the square root of x plus 1 minus square root of 2x divided by 1 minus x as x approaches 1. Substituting directly, this gives you square root of, substitute 1 for x. So you have 1 plus 1 minus the square root of 2 multiplied by 1 divided by 1 minus 1. Okay, and if you evaluate this properly, you see that this gives us square root of 1 plus 1, of course, is 2, and then minus square root of 2 multiplied by 1 is 2, and then everything divided by, of course, 1 minus 1 will give us 0 at the denominator. So evaluating further, this gives us, of course, root 2 minus root 2, that collapses to 0 over 0. And I told you that whenever you are solving limit problem and you arrive at 0 over 0 after substituting directly, the next thing you do is to first of all do something. So we are going to do something to this particular function before we substitute our limiting or approaching value of x. What can we possibly do? Now, if you observe this critically, you discover that this is quite different from the one I did in one of my videos, where we have to first of all factorize, and there are some where you need to first of all apply your difference of 2 squared. But if you look at this, it is not of such. Okay, this is a radical function. Okay, anything that has roots, you need it is called a radical function. And when you have something like this, the best way to approach this is to rationalize. Okay, so let's look at that. So we have our limit of square root of x plus 1 minus square root of 2x divided by 1 minus x as x approaches 1. Of course, just the way we normally rationalize in SOD, of course. In SOD, though, we normally rationalize the denominator. But you can also rationalize what? The numerator. Depending on where the root is or depending on what you want to rationalize. You can rationalize numerator, you can also rationalize denominator. So in this case, you are going to be rationalizing the what? The numerator. Sorry for that. So, doing that, of course, we are going to first of all take the conjugate of the numerator. And what the meaning of conjugate simply means the change of sign. So we are going to take the conjugate of the numerator and then use that conjugate to multiply both the numerator and the denominator. That is how you rationalize. So let's do that quickly. So this gives us limit of the square root of x plus 1 minus square root of 2x divided by 1 minus x as x tends to 1. So you multiply the numerator by its conjugate. The conjugate here becomes square root of x plus 1 plus square root of 2x divided by square root of x plus 1 plus square root of 2x. Okay, what do you observe or what do you notice? You discover that the conjugate here is just for you to change this negative sign to positive and then use it to multiply both the numerator and the denominator. Okay, and then let's evaluate this. So this gives us limit of course, we are going to expand here. How do you do that? This first term, you're going to multiply these two terms here, and this second term here, you're going to multiply these two terms. And of course, don't forget this rule in sum. Root A times root A is always equals to A. Please take note of this. Which means that the square root of x plus 1 multiplied by square root of x plus 1 here will just give you x plus 1. Okay? And then square root of x plus 1 multiplied by plus root 2x. You're going to give you plus square root of this 2x. We multiply the x plus 1 inside the general root. And then this negative comes in. And then root 2x again multiplied by root x plus 1 will give you root 2x, open bracket, x plus 1. And then, of course, negative times positive gives you negative. And then root 2x times root 2x will give you 2x here. Sorry for that. And then divided by your 1 minus x here, we multiply this whole thing here, which is open bracket, square root of x plus 1 plus square root of 2x. Don't forget your x is approaching 1. Okay? And then from here, you can do some cancellation. This positive root 2x into this, cancel this. Because they are the same and they are carrying negative and positive. So they cancel out, okay? And then you'll be left with x minus 2x. Of course, this gives us limit of x minus 2x here will give you negative x and then plus 1. Everything divided by 1 minus x into square root of x plus 1 plus root 2x. Okay? Alright. Don't forget x approaches 1. Alright. Quickly, this is the same thing as limit. This minus x plus 1 is the same thing as 1 minus x. Everything divided by 1 minus x. Then you have into square root of x plus 1 plus square root of 2x. Okay? Alright. So you can see that this 1 minus x here eliminates 1 minus x from there. Okay? Alright. And then you'll be left with, don't forget your x is approaching 1 here. So you'll be left with limit of 1 up, then divided by the square root of x plus 1, and then being added to the square root of 2x as x tends to 1. And then from here, you can now substitute directly. Wow. So this gives us 1 up as your numerator, and divided by the square root of is your you're going to substitute 1 for x. So this becomes 1 plus 1, and then plus square root of 2 multiplied by 1. So this gives us 1 all over square root of 2 here, plus square root of 2 here. And of course, there's an invisible one here, invisible one here. So you can actually add these two together, and that gives us 1 all over, of course, 1 plus 1 here will give us 2 root 2. Okay? And in sort, when you have this kind of expression, you have to rationalize this. How do we do that? We multiply here by 2 root 2 all over 2 root 2. So this gives us 1 times 2 root 2 here. You have 2 root 2 over 2 times 2 here, 4 times root 2 times root 2 will just give us 2. This 2 eliminates these 2, then you are left with square root of 2 all over 4. Of course, square root of 2 over 4 becomes the limiting value of the given function as x tends to 1. Thank you for thank you for watching, and I want to beg you to always subscribe, comment, like, and share my video for more videos. Thank you.